Okay, now we're going to talk about limits at infinity. Now, this usually occurs with rational functions. Well, no. Limits at infinity occurs with any limits, but I have this is where we bring in rational functions because where we really get into things going berserk is with rational functions. And what we really want to look at is what happens to the graph of 1 over x as x goes to infinity. So we wanted, this is right here, this graph is the graph of 1 over x. So here's y, here's x, and this function is the graph of 1 over x. So I want to note some things that we see from this graph. So I want you to notice that the limit as x goes to 0 from the left of 1 over x goes to negative infinity. Because notice that this goes down and down and down and goes to negative infinity. And I want you to notice that the limit as x goes to 0 from the right of 1 over x goes to positive infinity. This tells us, these two together, tell us that the limit as x goes to 0 of 1 over x does not exist. And that is why we have a vertical asymptote at x equals 0. So x equals 0 is a vertical asymptote because that limit from the left and the limit from the right aren't equal, okay? And that limit does not exist. The other thing I want you to notice is that the limit as x goes to negative infinity of 1 over x equals 0. So as this graph goes off to negative infinity, this graph gets closer and closer and closer to 0, but it never hits it. And the limit as x goes to infinity of 1 over x equals 0 also, because the graph gets closer and closer and closer to 0 and never hits it. And those both are the definition of asymptotes. Now, the other thing I want you to notice is, the other thing I want to show you is I want to talk about this little principle. So if I have the limit as x goes to infinity of 1 over x to the n, by a property of limits, I can pull that exponent to the outside. So this is the limit as x goes to infinity of 1 over x to the n. But I know that this limit right here, we've already said that this limit right here is 0, so this becomes 0 to the n, which is now 0. Okay? Now, here's the other big thing that you need to know about all of this. All right? This is the biggest thing. Right here. The higher the power, the higher the power, the higher the, not power, the higher the exponent, let's say it that way, the higher the exponent, the more power. All right? So the higher the exponent, the more power. Okay? So in other words, if my higher exponent is in the denominator, so if my higher exponent is down here, then that means I have more power in the bottom and it goes to 0. If my higher exponent is in the top, that means I have more power and it goes to infinity. If my higher exponent, if they're the same highest exponent, then it's the ratio of the coefficients. All right? So let's go to some examples. Now, this is what I'm going to do. I'm going to make this a real short and sweet explanation, and I'm going to save the algebra one, and I'm going to do one of these by algebra, and then I'm going to show you the shortcut for all of them. Okay? But I'm going to do one by algebra, and I'm going to save the algebra one to be later. But I'm going to show you the shortcut, because if you use the shortcut, I'm happy with that. But I do want to show you how to do the algebra on at least one of these, because that's probably what you'll end up teaching. All right? So, the higher the power, the more power. The higher the exponent, the more power. If they have the same highest exponent, then it's the ratio. So do they have the same highest exponent? Yep, they do. So the answer is going to be 5/2, because same highest exponent. Ta-da, we're done. All right. This is the one I'm going to do with the algebra. So how you work this with the algebra is you're going to multiply the numerator and the denominator by 1 over the highest exponent. So that's x to the 10th. So that's 1 over x to the 10th. And the numerator and the denominator. So what you get is you get the limit as x goes to infinity over, the numerator becomes 5 over x to the 6th plus 20 over x to the 7th, all over 2,000 plus 5 over x to the 10th. Right? Because if I multiply, let's go down here and make sure you get this. 5 over x to the 4th over 1 times 1 over x to the 10th, then this x to the 4th cancels here, and this leaves x to the 6th. Right? So this gives me 5 over x to the 6th. All right? That's just a little sidebar just so you make sure that you understand the math that's going on there, the algebra. All right? So now, if I take the limit as each of these, as x goes to infinity of each of these terms, this term goes to 0, this term will go to 0, and this term will go to 0. So what I'm left with is 0 over 2,000, which is 0. All right? So this whole limit equals 0, which we said before, the higher the power, then it goes to 0 faster, so this limit would be 0 because the highest exponent's in the denominator. But what I've done here is I've shown you the algebra of how to get that. Okay? Now, for this one, the highest exponent's in the numerator, so the higher the power, the faster it goes to infinity. So this would be d and e, because the highest exponent is in the numerator. And you're done. All right? So if you have any questions on this, please email me and let me know.